Next up, solving linear equations and linear inequalities. Number 1. If 9 is greater than or equal to 4x plus 1, which inequality represents the possible range of values of 12x plus 3? So let's begin with our initial inequality and subtract 1 from both sides. This gives us that 8 is greater than or equal to 4x. And we want to know the possible range of values for 12x plus 3. So we're going to have to triple this and add 3. Of course, you could divide out the 4 to get x by itself, but to go straight there, we can, at this point, multiply by 3 on both sides. This gives us that 24 is greater than or equal to 12x, and if I want to add 3 to both sides, I can simply write plus 3 and plus 3. Or in other words, 27 is greater than or equal to 12x plus 3. So if you're confused because the 27s are on the right, here for C and D, pay attention to the direction of the alligator's mouth. It's open toward 27. That's why D is correct. Number 2. 6 is equal to negative s plus 77. Given the above equation, what is the value of 1 plus 5 times the quantity 77 minus s? Well, a key to recognizing where to start in this problem is that negative s plus 77 is the same thing as 77 minus s. Addition and subtraction in a different order this way. They still have the negative with the s and the positive with the 77. They're the same thing. So therefore, 6 can be substituted in for this quantity. And this gives us 1 plus 5 times 6, or 1 plus 30, which is just 31. C. Number 3. If 16 minus 7w is equal to w plus 14 minus 6w, what is the value of w minus 1? So the first step is to combine like terms here on the right side. And this gives us negative 5w plus 14. The next thing I can do is move all the numbers to the right and all the variables to the right and all the numbers to the left. And I do this by adding 7w to both sides. And I get 16 is equal to 2w plus 14, and then I subtract 14 from both sides, and I get that 2 is equal to 2w. So if I divide this out, w is equal to 1. Remember earlier in the problem they wanted to know what is the value of w minus 1. So w is 1. If I subtract 1 from that, w minus 1 is 0. Number 4. If 1/2 plus 2/5 s is equal to s minus 3/4, what is the value of s? So I can begin by subtracting 2/5 s from both sides. On the left this cancels out and I'm left with 1/2 is equal to 3/5 s minus 3/4. Next up I'm going to add 3/4 to both sides. On the right this cancels out. On the left, I can convert 1/2 into 2/4. They're the same thing. This allows me to add because I have the same denominator. So I have 5/4 s is equal to 3/5 s. Excuse me, there's no s here on the left. Just 5/4 is equal to 3/5 s. To cancel out this 3/5, I can multiply both sides by 5/3. So I have 5/3 times 5/4 is equal to s. 5 times 5 is 25. 3 times 4 is 12. 25 over 12. If I look back at my original answer choice, that was B. Number 5, 15x minus 3 is equal to 9x plus 1. So I notice that there's a larger x coefficient on the left. So to avoid a negative, I will subtract here on the right. This cancels out, and I have 6x minus 3 is equal to 1. I'll add 3 to both sides. This gives me 6x is equal to 4. When I divide both sides by 6, I get x is equal to 4 over 6, which can be reduced to 2 over 3, because I'll divide both of these by 2 to reduce it. 2/3, C. Number 6, 4 plus 5m is equal to 4m plus 1 plus m. If I combine like terms on the right part of this equation, I get 4 plus 5m is equal to 1 plus 5m. I can subtract 5m from both sides, and I'm left with 4 is equal to 1. That's not a true statement. Therefore, the equation has no solutions. Number 7, if 15bx minus 20 is greater than 35, where b is a positive constant, which of the following best describes all possible values of 4 minus 3bx? So to get from 15bx minus 20 to these values here, I had to divide by something. It turns out, if I divide the entire thing by a negative 5, 15bx becomes a minus 3bx. Negative 20 becomes a positive 4, which is what this is in the opposite order. So I also had to divide the right side by a negative 5. And if you remember anything about inequalities, dividing by a negative reverses the sign. So now this quantity, negative 3b plus 4, or 4 minus 3bx, has to be less than negative 7. Number 8. If negative 18 is greater than or equal to 6 minus 12ax, which inequality represents the possible range of values of 1 minus 2ax? So we'll begin with negative 18 is greater than or equal to 6 minus 12ax. And we are dividing this by 6. So we'll divide here by 6, divide here by 6, and divide here by 6. And we end up with negative 3 is greater than or equal to 1 minus 2ax. So the possible range of values here, notice the alligator's mouth is facing the negative 3. C was our best choice. Number 9. 4c plus 5 is less than 4c plus 3. If I subtract 4c from both sides, they cancel out, and I am left with 5 is less than 3. Is that a true statement? No. Therefore, no solution. Number 10. If 9 is greater than or equal to 4x plus 1, which inequality represents the possible range of values of 12x plus 3? So how can I get from 4x to 12x and from 1 to 3? In fact, I multiplied by 3. So on the left, I must also multiply by 3. And this gives me that 27 is greater than or equal to 12x plus 3. Notice the alligator's mouth is open toward the 27. That's why D is correct. 11. 6 is equal to negative s plus 77. Given the above equation, well, this is a repeat problem, so we plug in a 6 here, same as before, and 1 plus 5 times 6, or 1 plus 30, is equal to 31. Number 12. If 16 minus 7w is equal to w plus 14 minus 6w, what is the value of w minus 1? Similar repeat problem.